Question 5-1. 12 years to bond maturity with a par value of 1,000. Interest is paid annually on this coupon bond with a rate of 8%. The bond has a yield to maturity of 9%. What is the current price? So this question may appear a little confusing at first, so we want to dig into it and understand what's going on here. Again, the par value of this bond is 1,000. That's the face value. But it's selling for a different price today, and that's why we're solving for the current price of the present value. It has a coupon rate of 8%, and that is used to calculate the coupon payment relative to the par value. Recall, the coupon payment is equal to the coupon rate times the par value of the bond. Next, we know that the yield to maturity is 9%. And what does this mean? It means if we buy this bond today, it's going to provide us a return of 9%. You may ask yourself, well, how can that be if the coupon rate is 8%? Well, something's happened in the market. That is, the rates have gone up. And so this bond has to adjust in price to reflect the rate in the market, or what's known as the yield in the marketplace. So if we were to look at the cash flows, it would look something like this, where if we bought this bond or at a given price, right, there was a cash outflow at time 0, and that's what we're trying to find, up through year 12. And so we know that there's a coupon payment of $80. And so this coupon payment is received for the next 12 years. Lastly, at the end of year 12, we receive our return of principal. So what we know is we have cash flows for the next 12 years of $80 and a return of principal of 1,000. We want to figure out how much we would have to spend today so that we have a return of 9%. That is, or if we discount this at 9%, what is the PV? So we could go ahead and guess. We could start by using the function NPV. And say, well, is equal to NPV with our rate of 9%. And then we would add back in our values, close, and then what we have to do is add back a negative value for time 0. So right now this is obviously not going to work. What we can see is it's actually worth $928. So that actually right there tells us what the present value, or what that bond would currently sell for. Another way to go about doing this is to use the PV function. So you say PV is equal to the rate, 9%. We know that there's 12 payments. We know that we receive an incremental payment of $80. That's the coupon payment. We are going to receive $1,000 in the future, and we're paid at the end of the period. So by default it's 0, but we'll go ahead and code it. We can also see that it would be $28.39. So again, what this is telling us is, in the marketplace, interest rates have gone up. That is, if you buy the bond currently, it'll provide a coupon rate of 9% to reflect the yield in the marketplace. But this bond only pays 8%. Because it only pays 8%, the price has to fall, so now that the bond does offer a return of 9%. And it offers a return of 9% because now it's at $928.39 rather than $1,000.